Hello everyone and welcome to our YouTube channel, that is CodieTro. In today's YouTube segment we are going to learn as to how to convert a number that is in the decimal number system to binary number system. So we all must be familiar to what is a decimal number system and what is binary number system. Let's take an example as to how to do that in using pen and copy. Today we are going to discuss as to how to do in programming language, but first of all let's try to understand how to do it with pen and copy. So let's say that we have a number that is 4. So what we do, we divide 4 by 2. When we divide 4 by 2, we see that the remainder left is definitely 0 and the quotient that is left is 2. So we divide again the number that is the quotient left with 2, and the remainder that is left is 0 again, and the quotient left is 1. So at last when we divide 1, that is the left quotient, with 2, we see that the remainder left is 1 and the quotient this time is 0. So once it turns 0, we just have to stop the calculation, we just have to stop the loop, we just have to stop the programming, and the number that we are left with, that is 100, is the binary equivalent of the number 4. One point that we have to note is that you see that the first remainder was 0, the second remainder was 0, and the third remainder was 1, but we have not written 1001 as the binary equivalent. We have written 100 as the binary equivalent, which is the correct representation of the equivalent of 4. So we just have to go it in the opposite order, which we will take care in the programming today. So before I begin the video, I will not be going through the conventions of writing the obvious things, so let me just paste it. Okay, first of all let's input a instruction for the user so that he has to enter a number, right? So I will just do cout enter a number, and we will just end the line because we have to enter because we have to take an input from the user here. So let's just define an integer bin, that is we have to now enter it from the user. Please understand one point, that do not confuse us the decimals like 2.1. if we write, this is not a decimal equivalent that we will be finding here, right? If you think that it is in the decimal number system, so it has to be 2.1. No, in this video we will not be going to deal with that. In this number we will only be dealing with positive integers. However, I believe that whether for 2.1 also we can convert it to binary equivalent, right? So we have just inputted the number from the user that is in the decimal number system. Let's go with a loop now. While the number that is bin that is not equal to 0, once it is equal to 0, we will stop our calculations and we will stop the loop. As I have already said that we first divided by 2, so let's define an integer type function for that as well, which will remain the integer only, which will store the integer. So integer rem that has to be equal to bin modulus function 2. One thing which we will understand is that rem will only be able to store 0 and 1 as the inputs. On the point, you see, if we will store the binary, right? Okay, let's just do one thing. Instead of using binary here, let's go with n, because the user is inputting the number in decimal number system, right? So let me just change it here. So we don't go through a confusion. Okay, so if we will just try to store the binary equivalent of the number that is n in the format of a string st, that will be easier for us to go through the calculations, because we have to go in the opposite order. When we go in the opposite order, it is a bit hectic in decimal and numerical type system. Let's just go with a string st. We have to give an output and the user does not know whether the output is an integer or st. He's just going to get a number that is the binary equivalent. So let's just void the string st, initialize it with a value that is a void value. Now what we are going to do here is we have to merge this st and this rem, that is the remainder. But the issue here is that st is in string format but remainder is in the rem format. For that, let us just make one more string value, that is string str. It is not needed to initialize this one. We can, but it is not an obligation here. Now let's just do one thing. Let's just convert the rem to string and take it in str. Okay, so now we have the remainder that was left. We have it in the string format now, and we can now concat the st and str, or we can add it together. But as I have already said that we will be going in the opposite order, so we will have to go with st is equal to str, and then only we will be able to add st, as I have already told you. Okay, now the last thing which we have to do is n is equal to n divided by 2, or if you are familiar with shorthand operators, we can just do n divided by 2 is equal to 0. Here the function of loop ends, and at the end of the loop we will have the binary equivalent of the number n stored in the format of stored in st, right? So just give an output to the user, that is the binary equivalent is equal to, and we have to give an output, that is st, right? We can end the line here, otherwise we cannot, since it is going to be the last output. And we will just go through the notions, of returning an integer. Let's say that we are to return 0 or something else. We can return anything actually. Let me just save the program and let us try to run it now. So as we can see in the output terminal, we have to enter a number. Let's say that we are to enter 12. So the binary equivalent of number 12 is 1100. That is correct and that is true. So I hope that you have understood what we were to do in this program. I hope that if you like the video, you will subscribe to us, you will like, and you will definitely share. That is all for today. Thank you.